Hello, and welcome to the Daily Space. I am your host, Beth Johnson. Dr. Pamela is taking a well deserved day off, so I am here to put science in your brain. As an astronomer, I can tell a generalized story on how planets formed that sort of goes like this. It all starts with a giant molecular cloud that one day collapses. Dust particles collide and build bigger and bigger structures until small, dust built planetesimals emerge. These smash together to form larger objects, gravitationally pulled in additional material, and otherwise find ways to grow. With planets, all traces of that original planetesimal get crushed to oblivion by the weight of materials above. With asteroids, it may be possible that in some cases that initial fluffy planetesimal survives. And it looks like with the asteroid Ryugu, it survived multiple potentially destructive processes. Thermal energy of Ryugu by the Hayabusa 2 spacecraft revealed the surface is randomly scattered with extremely low density boulders that are more like giant pumice stones than the high density boulders we're used to thinking of. These boulders are so low density, in fact, that they would float in water if given the opportunity. Researchers think these boulders may be fragments of those low density planetesimals that once made up Ryugu's core. We know Ryugu is a rubble pile created during one or more asteroid collisions. Collisions shattered the colliding objects, which then came together as a mixed up pile of rubble. By literally mixing the core fragments to the surface, this collision process revealed never before seen bits of fluffy planetesimals and confirmed at least our big picture view planetary, of planetary formation. So that's real. Yay. And now we know where future space travelers can get pumice like stone if they need it. This research appears in Nature Astronomy and is led by N. Sakatani. Testing our theories about other planets without actually having the tools to explore other planets to the greatest of depths is a challenge. We got lucky with Ryugu and nature broke it apart for us. With other planets, we just have to do the best we can by simulating their environments in our laboratories. Extreme environments, however, have remained beyond our technical limitations, and our ability to simulate things in a lab is just starting to catch up to our ability to imagine them in software. In a new experiment at the University of Rochester's Laboratory for Laser Energetics, researchers used diamond anvils, which we've discussed a few times this week, to compress a mixture of hydrogen and helium to pressures like those expected in Saturn's atmosphere. Pressures 40,000 times what we experience on Earth. They then used shock waves from lasers to compress things by another factor of about 15 to 45 times, and they looked to see what happened. According to study co-author Marius Milot, our experiments reveal experimental evidence for a long-standing prediction. There is a range of pressures and temperatures at which this mixture becomes unstable and demixes. Put another way, he says, we discovered that helium rain is real and can occur both in Jupiter and Saturn. This work appears in Nature and is led by S. Ryugu. We would like to remind all of you not to try singing or dancing in the helium rain because the conditions will kill you. Laboratory experiments are awesome, but actual data is always better, and some things just can't be built in our labs, things like entire solar systems. Ever since we started finding exoplanets in the 1990s, folks have wondered if our system is normal or not. Do other systems store their rocky worlds near their suns? Is it typical to have Jupiters and Saturns farther out? Understanding these questions takes time and technology. To confirm the existence of a planet, we really need to wait for it to complete an orbit, and the farther from the sun an object is, the longer it will take. Jupiter, its orbit is 12 Earth years long, and Saturn's is 29. Pluto, well, we haven't actually even seen Pluto complete an orbit yet. It was discovered in 1930 and will take 248 years to complete its orbit. To really understand what is going on, a survey of a large set of stars is required, and this is where the California Legacy Survey comes in. This survey is looking at 719 sun-like stars and is trying to identify the pulls and pushes of orbiting planets reflected in the stars' motions. This 30-year-old project has released data on 15 new planets that join its catalog of 177 worlds. While not sensitive enough to detect distant ice giants like Uranus or Neptune, this survey does see gas giants, and it finds that gas giants are most often found with orbits between the size of Earth's orbit and 10 Earth orbits. This shows our solar system is pretty typical in its planetary placement, at least in comparison to other systems we can see. With more time and more sensitive instruments, we'll be able to see more distant planets and a wider range of planet masses. This is a reminder that astronomy is a long game, and sometimes the experiments in spacecraft started by one generation are completed by future generations. After the break, we'll be back to look at how our world has preserved amazing fossils, while we dream of rovers finding probably less amazing fossils on Mars. Understanding the history of our own Earth is a bit easier than understanding the history of other worlds. On a good day, a random person walking across a random field or along a random cliff face has a non zero chance of discovering fossils sticking out of the Earth. The tongue twister, She Sells Seashells by the Seashore, actually tells the real world story of Mary Annings, a self made expert in fossils who made her living making careful observations and then collecting and selling fossils from the cliffs near Dover. While it's hard to imagine this kind of, there is a massive fossil find in front of me discovery today, it can happen. In the summer of 2020, a park ranger named Greg Francic was walking near the McClumney River watershed outside Sacramento and spotted what appeared to be a petrified tree, and then another petrified tree, and eventually even fossils of animals, all randomly scattered in what he and others would come to realize is a petrified forest that dates back to the Miocene epoch about 10 million years ago. This epoch is best known for the emergence of giant mammals, with early versions of the horse, camel, and sloth littering the fossil record, and mastodons. This was the age of mastodons, and in this newly discovered petrified forest, Francic and a team from Cal State Chico discovered a fully intact mastodon skull with the long tusks still attached. This COVID lockdown era discovery was protected initially by luck and now will be protected under the United States Paleontology Preservation Act. In the coming months, researchers from additional institutes will join the search for this new fossil find. This is a reminder. The only thing separating a scientist from a non scientist is the reporting of data. It is unknown how many hikers had seen this park's petrified wood and maybe even pocketed a few fossils. All it took to make this discovery was the curiosity to ask, what is this? And the scientific follow through to report what was found. Not every fossil discovery is made this easily. In some cases, in the opposite of the scientific method, folks see fossils, curse, and pretend they aren't there. Those people, usually they are the folks trying to build a road, dig a new foundation, or burrow into the ground for any many other reasons where delays will cost revenue. To prevent these accidental discoveries from getting ignored, many places in the world, including here in California, require a paleontologist or archaeologist to be present at construction sites. This has led to a weird situation for one soon to be closed garbage dump and its associated paleontologists in Spain. The Can Modif landfill in Catalonia, Spain, digs vast pits in sandy soil and then fills these pits with what the locals deride as extremely stinky garbage. During the 24/7 excavation that occurs, researchers from the Miquel Crucifont Catalan Institute of Paleontology watch for solid bits in the loose soil and pause the dig on a regular basis to collect bits of bone and sometimes even massive pieces of skeleton. In this garbage dump, the excavation comes as a necessary part of waste storage, and researchers are able to get samples of the past that would otherwise lack the resources to recover. So far, more than 70,000 fossils have been recovered, including some of the only examples or most complete examples of various early primates that are known. According to an article in National Geographic, their finds include the discovery of what is called a chalicotherium, a tall, knuckle walking, clawed ungulate that looks like a bizarre mix of giant sloth, bear, horse, and gorilla. They have also found one of the only early flat faced primates, which researchers think is a sign of convergent evolution leading to head shapes like ours more than once. While it is a bit terrifying to think about how many fossils are either broken in the excavation of this garbage dump or just plain missed in the rapid digging, what is more terrifying for researchers is the knowledge that local attempts to get this dump closed down could end their ability to recover fossils. Located relatively near Barcelona in a fairly densely populated area, locals have begun protesting the dump and its smell. If the dump is no longer an active waste facility, it will be sealed off for safety and the paleontologists won't be able to dig. Not that they'd have the budget for the dig either. This is the kind of science that gives me extremely mixed emotions. Humanity's production of garbage is vast and environmentally destructive. No one wants to live near a dump, and I feel for these people. But the science that is being done is amazing. I guess fundamentally, the sadness comes from the realization that there will always be more funding to dig to build houses, roads, and garbage dumps than there will ever be to just dig for the sake of science. After the break, we're going to jump planets and take you off of this world. Stay tuned. Hunting for fossils isn't just an Earth based activity anymore, at least not in theory. There are a lot of people discussing the possibilities for life on Mars these days, and one of those discussions is about finding evidence of past life. A few people are talking about finding evidence of current life. But none of our rovers are in a place or equipped or even allowed to intentionally look for physical signs of life. Perseverance is in a lake bed, it's true, but it is not allowed to venture over to the nearby river delta where microbial life might have been abundant. While there is an agreement to keep spacecraft free of biological contamination, it's never a guarantee, so scientists act out of an abundance of caution. Oddly enough, there's also a push to send humans to Mars so that they can do the research that the rovers cannot. After all, there's only so much onboard analysis we've managed to place on these rovers, and human hands and eyes are an incredible scientific set of tools. We have a lot of problems to solve before we can send people to the red planet, though. It's not habitable for us by any stretch. And as always, one of the things on the checklist is access to water. New research published in Icarus and conducted by graduate student Shannon Hibbard at Western University in Ontario provides evidence for past ice streams under the surface. Not only that, but the ice streams are in a relatively flat, low lying region of Mars called Arcadia Planitia, which makes it a potential landing spot for future astronauts. Hibbert explains, "We have not seen anything quite like this on Mars, so we look to Earth where streams of ice within ice sheets can exist with no obvious control from surface topography. On Earth, these are known as ice streams." However, Hibbert and her team cautioned that these results are not evidence of water on Mars. We still don't fully understand what causes ice streams here on Earth. Hibbert goes on to explain it is likely that subglacial waters play an important role in ice stream initiation and flow, especially where surface slope is low, like what we see at the sinuous features in Arcadia Planitia. So it is possible that at some point subglacial water was present at this location on Mars, but it is unclear how much and for how long. Speaking of water and possible life on other worlds, one of our other favorite icy moons is in the news again. An international team of researchers has published new work in geophysical research letters detailing observations and modeling of Jupiter's moon Europa and how the tidal forces from Jupiter and the other Galilean moons may cause enough inner heating for Europa to have volcanoes on its seafloor. Europa is an icy moon with a vast subsurface ocean, and the reason the tiny world, not much smaller than our own moon, is the subject of so much interest and speculation is that that ocean could have seafloor volcanoes similar to what we have on Earth. On Earth, those volcanoes also create hydrothermal vents that spew hot metallic clouds, and life can be sustained on that material. If it happens once, it could happen elsewhere. The big question has been whether or not Europa has enough internal heat to create a magma layer. And this new research says yes, yes, it does. For the press release, the research models in detail how Europa's rocky part may flex and heat under the pull of Jupiter's gravity. It shows where heat dissipates and how it melts that rocky mantle, increasing the likelihood of volcanoes on the seafloor. All of this work is being done in anticipation of the Europa Clipper mission, which is currently scheduled to launch in the mid-20s and arrive at Europa in 2030. Between this news, the upcoming mission, and all the work being done on Mars, I think we're going to find evidence of at least microbiologic life on another world in my lifetime. One last break, and then we'll be back with this week's What's Up. Stay tuned. If you didn't get out the last 2 weeks and check out Mercury in the evening sky, there is another cool event coming up this weekend. It's actually going to be more difficult because it's going to be in close conjunction with Venus. This will be the closest visible conjunction until 2033. You'll probably need at least binoculars to differentiate the two, though, as Venus is just so bright, and Mercury is a waning crescent, so it's even less bright than when we sent you all out to look earlier this month. However, if you can get a clear view to the western horizon at dusk, give this pair a look, and please share any pictures you happen to take. You can tag us on Twitter, where we are at CosmoQuestX. If you live near New York City, now is the time to go see a curious phenomenon called Manhattanhenge, where the sun lines up nearly perfectly along 42nd, 34th, and 13th Streets in Manhattan. This is a twice a year event, and this year the first occurrences, they come in pairs, are on May 29th and May 30th at about 8:10 p.m. Eastern. The next time this phenomenon occurs will be in July on the 12th and 13th at 8:20 p.m. Eastern. This is a pretty neat little happenstance. Scientific American explains the phenomenon is based on a design for Manhattan outlined in the Commissioner's Plan of 1811 for a rectilinear grid or gridiron of straight streets and avenues that intersect one another at right angles. This design runs from north of Houston Street in Lower Manhattan to just south of 155th Street in Upper Manhattan. Most cross streets in between were arranged in a regular right angled grid that was tilted 29 degrees east of true north to roughly replicate the angle of the island of Manhattan. And because of this 29-degree tilt in the grid, the magic moment of the setting sun aligning with Manhattan's cross streets does not coincide with the June solstice, but rather with specific dates in late May and early July. So if you're in the area, give this view a chance. We'll have links to where to see it from in our show notes on dailyspace.org. For now, though, this has been the Daily Space. You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.